Okay, so this is your pre-lab low and high pass filter. Okay, so here we have made RC low pass filter, and you know what is filter? Low pass filter will allow the low frequencies to pass through it, and it will block high frequencies. Okay, so these are the passive components. So here we are going to construct a circuit using passive components, and we will see that how it will act as a low pass filter. Okay, so we will take this 5 volt 106 hertz AC power source. Okay, in the hardware we use this from function generator. Okay, then we have 1000 ohms resistor, and then we have a capacitor of 470 nanofarad, and with the ground we will complete the circuit. So I have made the circuit here. So I have 5 volt 106 hertz, 1 kilo ohm resistor, and 470 nanofarad capacitor. Okay, first I will and then I will use this input probe and this output probe. In the hardware we use this channel 1 of oscilloscope, channel 2 of oscilloscope. Okay, we will select from here interactive, and then we will run it. We will go to the grapher, and then we have this green input and the blue is output. Okay, for the blue peak, for the green, we can use cursors. It's 4.9859 volt, which is correct because our input is 5 volt. Or we can select, we can just do it like this also, 4.9925. And for the output we have 4.7 volt, or we can take cursor and then 4.74, and this one at the peak. Here this peak, so this is 4.924 volt and output is 4.79 volt. Take the cursors and then take screenshot. Okay, then you will go to your lab sheet, and here you will put 4.99 volt or 5 volt. It's up to you because it's 5 volt, and this 4.77 volt. Okay, with 106 hertz frequency. Then what is the voltage gain? So gain we will calculate by 20 log to the base V output divided by V input. So V output is 4.7 divided by V input is 5. So we will get this answer. Okay, similarly delta, how you will get is theta out minus theta in. So same method, you will put it at 0 of input, and then you will put it at 0 of output, and then you will check this delta, which is 413 microsecond. You will take this screenshot, and 430 micro multiply by 360 and multiply by 106 will give you this answer. Okay, and as this is a capacitor, so we will use minus sign. Okay, then this part is done. Now we have two more things, which is the cutoff frequency. We have cutoff frequency and we have phase shift at cutoff frequency. Okay, so where the gain is -3. If you see this picture here, so here you see where is the cutoff frequency at -3 dB. At -3 dB gain, we get the cutoff frequency. How we will get that on multisim? We will go to multisim, and from here we will select AC sweep. Okay, and we will run it. So now here we need only this blue, which is output. So we don't need V1. We only need V output. So cursor 1 we will put at the maximum value, and cursor 2 at -3 dB. Okay, one more thing, we have to change the scale from logarithmic to dB, and now we can take it to -3 dB. So minus, okay, almost -3 dB, -3.07, -3 dB. This is the cutoff frequency, which is 341.5, and then angle is -45. You will take this screenshot, and then you will fill this 341.52 hertz you will write it here. Okay, it is equals to 341.52 and angle is minus 45 hertz. Okay, so you will take one screenshot. Okay, so this is the same thing. Then you will change the frequencies and then you will get these values. So here you will do this simulation for low pass filter, and then here for the high pass filter you will take one screenshot of this circuit, which is this circuit, second screenshot for this AC sweep analysis, and the third screenshot for third screenshot with this phase cursors, and fourth screenshot for peak value. Okay, you can take that with these two cursors. Okay, so that you will get input and output both values. So that's it, and you will do the same thing for the high pass filter. This was all about the low pass filter, so you will do the same thing for the high pass filter, and then you will fill this table. This table is for high pass filter, this table is for low pass filter. Okay, and yes, that's it. So please do this before coming to the lab on Wednesday, and then before coming to the lab on Tuesday, and then also on Wednesday. So that's it. Okay.